All right. Hi, welcome in everybody. Today we'll be hearing from Ayushi, Srijan, and Rangesh, and they will be talking about stay or go, predicting customer churn through graph relationships. And I will hand it over to you all to begin.
Yeah, thank you, Aiden. Good morning, everyone, and welcome to Nodes 25. We are excited to be here today as part of the data intelligence track. I'm Sridhar, and I'm joined by my colleagues Ayushi and Rangesh. Chandrasekhar unfortunately couldn't make it today, and we'll be exploring a critical business topic, which is predicting customer churn. So specifically, we'll be exploring how leveraging graph relationships can provide like unprecedented insights into this challenge. These are the speakers as I just introduced, right? So let's just begin. Customer churn is a persistent threat to growth and revenue. In today's competitive landscape, understanding why customers leave and most importantly, predicting who might leave is paramount. We believe that by connecting data to predict disconnection, we can revolutionize how customers or businesses approach customer retention. Okay. As you see, right, the title itself says connecting data to predict disconnection. So this encapsulates our central thesis. Customer churn is one of the most significant challenges in the businesses today. The financial implications are substantial, from lost revenue to high cost of acquiring new customers. And we are having like traditional models. Why not traditional models, and why also include a graph model, right? There are certain limitations to the traditional approaches. Traditionally, churn models have often focused on analyzing customer profiles in isolation. They often look at individual data points without considering the web of interactions and influences. But here is the crucial insight: churn rarely happens in isolation. It's almost a result of a series of connected events and relationships. Now, let me introduce you how we are going to solve this problem by using graph, right? And especially Neo4j. So, Neo4j, a leading graph database, comes into play here. By modeling customer behavior as connected graph, we can move beyond isolated data points, and we can connect like multiple data points together to reveal the hidden relationships. This will let us know what truly influences whether a customer decides to stay or leave. We will show you how connected data behaves here, and we'll provide you a much richer and more accurate understanding of churn drivers. Okay, now we have the challenge, which is the customer churn, right? So what are the implications of customer churn? First thing is we have the impact itself. Let's dive deeper into the challenge, right? Every businesses, regardless of the industry or the size, grapples with churn. It directly impacts their growth trajectories and erodes revenue. This constant need to replace lost customers is not only costly, but also diverts resources from innovation and expansion. Next, we have the complexity of the prediction. Predicting who will leave, and more importantly, understanding the why, right? Which is incredibly complex in today's world. Traditional churn models often rely heavily on transactional data or static customer attributes. While these are important, they often paint an incomplete picture. And final thing, which is the main problem that we are going to solve, the hidden influences and siloed data. The real difficulty lies in tracking indirect influences, things like peer behavior, social connections within a service, or dependencies on other services. This kind of relational data is often siloed across different systems, leading to fragmentation and incomplete insights. As a result, interventions are often delayed, reactive, or even misdirected, making them very less effective. Now, I will be handing over to my colleague Ayushi, who will walk over through the Neo4j architecture, and she'll be going over through various GDS algorithms we have employed for the solution. So over to you, Ayushi.
Yeah, thanks, Sridhar. So let's go over why the traditional models failed, right? So as Sridhar has mentioned briefly in the previous slides, the fundamental flaw over here is that the conventional machine learning approaches, they rely very heavily on tabular data, spreadsheets, and the use of metrics, right? So the fundamental flaw is the focus on isolated attributes rather than the intricate network of relationships. So they might tell you what a customer did, but not who they interacted with and how those interactions influence the behavior and why certain patterns changed, right? So there are a lot of hidden patterns. Now, these isolated view causes them to miss crucial hidden patterns across various aspects of the customer journey. So you think of a customer activity not just individual actions, but sequence and dependencies. So consider complaints and support history. So there are clusters of users experiencing similar issues, or about the nuances of subscription life cycle. So for example, a customer might not churn because of their own issues, right? So they might churn out because a close peer in the network has churned out, or a sudden drop in the connected clusters engagement can signal like a community level churn event. So ignoring these relational dynamics limits the predictive accuracy, and it causes a lot of false negatives. So without understanding these connections, the predictive power is severely limited. So what is the cost of isolation over here? So if, as we have stated on the slide, the isolated data leads to isolated insights. So this isn't just a catchy phrase, it's like the profound truth. So when your data is fragmented, when it's in pieces, your understanding of customer behavior will also be fragmented, and your decision making will also be inaccurate. You so it will be like an uphill battle managing customer churn. So, going over to the next slides, yeah, now we'll discuss some of the early warning signs of churn that we have identified through our process. So, some of the observable indicators are like, before a customer churns, there are some small warning signs or some big major warning signs. So, these are not always obvious in a very traditional tabular data set, but they become clear when they view it through a relational lens. So, a decline in interaction frequency or engagement scores is one of the classic indicators. So, a customer who was once very active on the network but now is very less active. So, there are unresolved and repetitive complaints that are another major red flag, right? So, if a customer is repeatedly experiencing issues, or if their complaints aren't being addressed effectively. So, for example, due to inefficient backend handling operations, the customer order is always flagged and their account is corrupted. It corrupted to the point that it causes constant friction, and that will lead to the irritation in the customer behavior, right? So the likelihood of the churn increases significantly. These are like some very obvious factors. So expired or paused subscriptions, those are like direct signals. So if suppose I've had like Netflix for like a couple or for a year, and suddenly I've stopped the subscription, that will be a major red signal. Also consider like disconnection from community or service networks. So a customer who was part of like a vibrant community, but now they have withdrawn, right? So these are some of the major red flags, and there are some social and network effects as well. So a decline in the referral or peer activity, that can also indicate a weakening connection to your service. So imagine like a heat map or a radar dashboard visualizing these metrics. It would quickly give us the insight and which are the areas of concerns. So by identifying these early warning signs, we can intervene proactively rather than reactively. So all these warning signs, when you look at individually, it may or may not give us insight, but when they are correlated, when they're interconnected, the patterns emerge. So that's when we see the magic happen. So that's where Neo4j comes in, that with helping us connecting the dots. So let's shift our focus into the graph-based approach with Neo4j. So at its core, Neo4j allows us to connect all these small pieces, right? So it isn't just about storing data; it's about effectively representing the relationships. So in Neo4j, as we all know, we start with the basic whiteboarding of the idea. So that is exactly what we did. We took nodes relationships. So over here, each node represents an entity, which can be like a customer or a product or a support ticket or a marketing campaign and so on. So, and critically, each relationship represents an interaction or connection between these entities. So, this is where the power lies. So, instead of separate tables, you have a living, breathing network of valuable information. So, this also helps us see the entire picture. The relational model, it will help us visualize a series of like supporting tickets, customers, combined with a specific product usage pattern or community connections, and all interact to drive a customer's overall behavior. So in, for example, like a certain geographic region, there is like a new promotion or a marketing strategy that has failed, causing customers to disconnect or abandon your service. So in the, if the neighborhood is intricately connected, the peer influence factors will be high. That will be one of the high factors to look at, and it will cause rapid churn rates. So the holistic view is essential for understanding these complex dynamics. So let's move on to what are the advanced churn predictions that we have used. So first we have whiteboarded the idea. We have the basic nodes and relationships, basic entities to look at. Now with the graph database, we can move on beyond the basic analytics and employ all the flavor of algorithms that GDS has to offer, right? So they are designed specifically to leverage the connected nature of the data. So imagine seeing a sequence like a decreased usage leading to complaints, which leads to inactivity. So this provides the actionable insight what we are looking for. So let me go over some of the examples of the algorithms that we have used and how they have like helped us. So firstly, very popular, we have community detection. So over here, like the weakly connected component or the Leuven or k-means, we have used that to identify like a group of customers who frequently interact on a support forum and are experiencing similar product issues. So it indicates a potential churn within that community. Or discovering that the customer in a specific geographic region connected by the shared local events, they show a collective decline in the engagement after a service change. So that is where community detection can help us. We also have similarity algorithms where finding customers who exhibit similar browsing patterns or purchase patterns to recently churned customers. It allows us to proactively intervene before they leave, right? So if suppose the churn customers have had browsed a particular service and opted for that particular service, which did not really work for them, then we can control the usage of that service for the next customers who are browsing the same similar pattern, right? So grouping the customers based on the service usage habits also, it reveals that with low usage of a particular feature, they are more likely to churn, even if the overall activity is moderate, right? So even if they are being like a normal customer, but there are certain small indicators, they might suddenly stop using a part of the service that they were once very active on, which is not might be not relevant for every case, but it can be subtle indicators that we cannot miss. So we also have topological link prediction. So predicting which customers are likely to disconnect from a specific service or community based on the weakening of their existing connections over time. So for example, like forecasting the formation of new positive connections between customers and the new products. So indicating like that there can be an increased engagement and then reduce churn risk, right? So it can also help us identify what are the new customers to attract, new customers to bring in. We have like centrality measures such as degree centrality, closeness centrality, betweenness centrality, and page rank, of course. So these help us pinpoint within the clusters that we identify earlier the highly influential customers within that social network. So if they churn, it could trigger a cascade of churn among the connections, right? So identifying the critical service nodes or like support agents who are central to many customer interactions. So suppose a certain agent is not able to handle the interactions or not able to handle the customer complaints effectively, might be the leading factor of your churn numbers. So the performance of those support agents, it directly impacts the customer satisfaction. Lastly, we have graph embeddings. So interactions as numerical vectors. So all these data that we have applied the algorithms on, we finally convert that to vectors, which can be easily used by machine learning models to predict churn with a higher accuracy. So a streaming service, is, for example, like a streaming service observes that a customer frequently uses a niche feature. Like, for example, I gave the example of Netflix earlier. we have like watch party for shared viewing, right? So they are, if a customer uses that frequently, they are less likely to churn. However, if the traditional models might not easily connect the usage of this specific feature uh, to overall churn risk, then it's not like a direct billing, because it's not like a direct billing or engagement metric, right? But using graph embeddings, the service could identify a subtle, non-obvious relationship. So customer who stop using the watch party feature, even if their overall viewing hours remain moderate, and whose connected friends, they also show a decline in the watch party usage, so they will have like a higher probability of uh, getting churned out. So this indicates like a weakening social connection within the circle within the service, and a factor that the traditional and isolated data analysis it might overlook. So coming to the architecture, right? I'll quickly walk over to the overall architecture that we have designed. Our system ingests data from various sources. It includes the traditional customer relationship management system, the billing platforms, the support ticket systems, but we also integrate the less structured data, such as the web application and the web and the application logs. And they capture the user behavior and even social media data, which can provide insights into sentiment and influence. So that goes into the ETL and the graph processing layer. So once the data is ingested, this diverse data is transformed into Neo4j nodes and relationship. So here it undergoes a powerful processing layer where we apply various graph algorithms. This includes like the community detection, similarity, etc., that we had discussed earlier. Now we use link prediction to anticipate future connections or disconnections, and the graph embeddings to translate these complex relationships into for the machine learning models. So now it's fed into our traditional machine learning models, and with the highly powered features from Neo4j, we take out prediction scores. So these prediction scores are then fed into visualization tools. Now, these visualization tools can simplify the interpretation of the complex outputs from these machine learning models. So it makes it easier to understand which factors contribute most to the churn predictions. So it can visually highlight the patterns and the trends in the customer behavior, and help in segmenting which are the at-risk customers and which are the customers who are more effective, who on whom the strategies, the intervention strategies have been effective or not. So we also have dashboards that can display the model performance and the metrics over time, allowing us to continuously moderate for quick identification in real time, and indicate like any degradation in the prediction accuracy. So they enable like clear and concise communication, churn insights into stakeholders for different on various departments and various platforms, right? So it will facilitate data driven decision making at the end of the day. So for with every system, there always comes certain improvements and enhancements that can always be made over time. So over here, we also have like a bunch of things that we would like to integrate and improve into our current system to help us better identify and catch churn patterns. So firstly, our work in this area, because it's constantly evolving, we want to include, we want to firstly integrate auto ML. So that is like a significant step. It allows us for the automated model selection, automated model building, and the hyperparameter tuning and optimization using the GDS pipelines. So it reduces manual effort and accelerates the time into the insight. So next we have like dynamic graph updates. This is to ensure that the models are always working with the freshest data, reflecting the real-time changes in customer behavior and churn risk calculations. So we want all real-time data coming in and coming in into the system and accurately tuning into the models. So we also have enhanced visualization, which is crucial for making these complex graph insights accessible and actionable for the business users. So by integrating things like Bloom and GraphXR for interactive customer behavior exploration, we'll be able to further strengthen the business users. So we have also heavily invested in explainable AI. So this provides transparency into why a particular customer is predicted to be churn, right? Using the interpretable embeddings, and it also helps build trust and enables in more targeted interventions to the customers. So we also have future enhancements which include edge weight optimization, where we dynamically assign the relationship weights based on the interaction frequency or sentiment. So it will help us give us more accurate predictions. And finally, we have cross-platform APIs. So this will help us ensure that the powerful churn prediction capabilities can be seamlessly integrated into existing business intelligence tools and operational workflows, which can expose the graph-based insights through REST API or GraphQL for seamless integration back into the CRM dashboards. So lastly, let us discuss some of the outcomes and benefits from the results that we have seen. So some of the tangible outcomes and benefits for adopting this graph-based approach um, is, first and foremost, we see a significant increase in the accuracy to identify the potential churners compared to the traditional machine learning isolated data that we were employing earlier. This isn't just about identifying some churners, but identifying who are the right churners with a higher confidence. And this accuracy translates into powerful insights that can be leveraged across the organization by the marketing teams to create targeted campaigns, by the support teams to proactively address the issues, and by operations to optimize service delivery. So these insights, they enable timely outreach, moving from reactive firefighting to proactive management and proactive engagement. So lastly, we also have like sustainable growth. So ultimately, all these efforts, all these things that we are doing, it leads to personalized retention strategies. So instead of like a one size fits all approach, we can tailor these interventions to be to be very specific to certain customers which might be at risk. So if a customer receives a tailored treatment, it will help us obviously retain the customer, better customer relationship, better experience for the customer, and overall higher satisfaction rates. So the cumulative effect of these benefits is the growth through significantly improved customer lifetime value. So this is like another metric that we um, kind of evaluate. So it ensures the long-term health and profitability of our business, right? So in closing, we have explored how a graph-based approach with Neo4j fundamentally transforms our ability to predict and prevent customer churn. So thank you for joining us today. We will encourage you to explore how connecting your data can lead to more connected and loyal customer base. So I think we have a few minutes to take a couple of questions. Yeah. So thank you all.
Thanks, everyone.
Hey, I think there's a question on what ML algorithm to use. I mean, for me on Koji, or if you guys can. I mean, basically, I think Chen is asking what ML algorithm can we tie up near Koji, with they support anything of that sort.
Yeah, there are a variety of algorithms you can employ based on what score you're trying to predict. So it can either be XGBoost or it can be your k-means algorithms for the clustering. So it depends on what flavor of algorithm fits your use case, right?
So just to add to it, like it depends on the use case itself. Like just to predict the target variable, we can try a variety of algorithms, as Ayushi mentioned, and in this slide you do see customer lifetime value, right? So we do have regression models in place for this, using which like we predict this value. Obviously, with the features that we have deployed through graph algorithms, right? Like we do extract variety of features by using centrality algorithms and other features. So just on top of the feature store features that we have, the graph features enhance our value like so much. So it gives so much value to the existing models, and it enhances the models like much better. So that's what we have observed.
I think we have one more question. I think we are just 3 minutes away, but still, I think we have two questions. So one on Python library suggestions, and the other one is to how do we ensure the effectiveness and robustness of our work? How basically it talks about the evaluations, like how what techniques are we using for evaluating. And the other question is on the Python library. I mean, most familiar Python libraries to take up this work.
So for our use case, like in terms of the libraries, right?
So
Yeah,
Okay, go ahead. Go ahead, Shiv.
yeah. Sorry. So so when you talk about Python libraries, right? Like whatever we do, like we have set up a pipeline through which like we extract the graph features from Neo4j, and we try to extract algorithms from the sklearn library that we have, right? Like we do like build MLP models on top of the existing features that we have, and the graph based features. So um, we have found like excellent results by using these couple of algorithms. One is MLP, because like traditionally that is a neural network based model, and that performs like excellent with the graph based features that we have found out by using our like use case, right? And then like when it comes to tree based models, like we have found like very good results with XGBoost. So uh, basically the way that the tree constructs these features by improving the performance over the previous trees, we have found like excellent results by using uh, this algorithm as well. And when it comes to evaluating the features, so we have set up sophisticated process to evaluate the performance, right? Like one is we do evaluate the model's performance like regularly by using we set up something called as gains table. So by using which we see like how the predictions have come up against the actual values. So that is something that we have set up, and on top of which we also evaluate how the features are itself working by using something like shapely explainer. So that is another thing that we see to just actually evaluate the features that we have. And this is something that we also use. And obviously on top of it you have the evaluation metrics for the classification and regression models, right? That is something which we like obviously use. So that is routine to machine learning.
Thanks, guys. I think we had a good
thank you,
session.
thank you, everyone.
And thank you.
Thank you.